in this video we are going to talk about parallel and perpendicular lines. So first let's start with parallel lines. When I think of parallel lines, I think of the side of the road. The left side of the road never meets the right side of the road. They stay the same distance apart no matter where we are. Otherwise, we have a problem. So that is what we mean by parallel lines. And what's really cool about the word parallel is if we write it this way, there is a set of parallel lines right here in the middle, just like our road. Okay, kind of cool. Now what we know about parallel lines is parallel lines have the blank slope. They're going to have the same slope. Okay, now remember, if something is in slope-intercept form, we can find our slope as our number in front of x. And to be in slope-intercept form, y is isolated all by itself on one side, nothing or nobody else with it. And then we can read off the slope. In this case, my slope would be 2. In this case, my slope would be 2. And so these would be parallel lines. Continuing with our road theme, when I think of perpendicular lines, I think of joining a T. And now I have a street sign similar to this down the street from my house. And what this means is I come to the end and I have to either go left or right. And what this means is we formed a right angle. Okay, so perpendicular lines meet to form a right angle. Please keep in mind they're not always this way. They're not always like a T. If I put them kind of kitty wonkas like an X, they still can meet to form a right angle. So while it's usually quite obvious we have parallel lines, it's sometimes not as obvious that we have perpendicular lines. What we know about perpendicular lines is that they have slopes that are opposite, and by opposite we mean different signs. No pun intended, right? Signs. One is going to be positive, one is going to be negative. And the word and here means that both of these need to be met. Reciprocal. Now remember what a reciprocal is. It is the flip-flop. So the reciprocal of 1/2 is 2/1 or 2. The reciprocal of 2/3 is 3/2. Okay, so the flip-flop. The top to the bottom and the bottom to the top, doing the old flip-flop. Okay. Yes, I write all my own songs. Okay. So an example of this might be if we had an equation of a line y equals 2x minus 3, like we do here. For it to be perpendicular, my new slope would need to be opposite. Well, this is positive, so it would be negative. And reciprocal. Well, the reciprocal of 2 is 1/2, so it would be minus 1/2 x plus any number we want here. Keep in mind this x is not in the denominator, it's up there. All right, so I have a few examples to show you. First, let's look at some parallel lines similar to the ones we just had. Y equals minus 2x plus 7, y equals minus 2x minus 4. To determine if these are parallel or not, we would look for the slope. Well, I see that y is isolated. And so if y is isolated, we have slope-intercept form, and that means we can just read the slope off. My slope in this case is minus 2. My slope in this case is minus 2. So these are, in fact, parallel lines. But be careful. What if I give you something like this? It's not obvious what the slope is. If you just jump in and read the slope, you would say this has a slope of 2, this has a slope of -3, but that is incorrect. We have to isolate our y. So what we're going to need to do first is do some algebra to isolate our y all by itself. So I have a 2x over here. I want to move that over by subtracting 2x each side. Minus 12y equals minus 2x minus 24. Next, I'm going to divide by -12. because to be in slope-intercept form, y has to be isolated. Now, when I divide that by negative 12, I have to divide every term by negative 12, or I will change the problem. These cancel out and leave me 1y. Negative 2 over negative 12 becomes a positive 1/6 x. And then negative 24 over negative 12 becomes a positive 2. So now that this is isolated, I know that my slope here is 1/6. Let's look at the second equation. Once again, I recognize that it is not in slope-intercept form, so I'm going to try to get it into slope-intercept form by adding 3x each side. 18y equals 3x plus 72 divided by 18, divide by 18, divide by 18. These cancel and leave me 1y. 3 over 18 becomes 1/6 with my x. 72 over 18 gives me 4 plus the 4. Now, once it's in slope-intercept form, meaning y is isolated, I can read off my slope. It's going to be right here, 1/6. And while it doesn't appear that these are parallel lines, when I get them in slope-intercept form, I see immediately they have the same slope, and that means they are parallel. Let's take a look at them on the graph, each of these two sets. Now, I'm using software called GeoGebra. I'm not going to show you how to use it in this video, but please feel free to access a different video talking about how to use GeoGebra. All right, down here in the input line, I'm just going to type my equation. I'm going to do the first two, y equals minus 2x plus 7. And then my second equation, y equals minus 2x plus, oh, it was a minus 4. In other words, we are, sorry about that, graphing these two equations. And now you can see that these are parallel lines, sides of the road, right? They run side by side, never meet, and they're always the same distance apart. Now, if I zoom out, it appears that they're getting closer, but that's just my zooming. Okay, notice that they never meet. Right, let's take these two off and graph the second that I had, y equals 1 over 6x plus 2 was one equation. Y equals 1 over 6x plus 4. Again, parallel lines. Side by side, never cross, same distance apart. Now, let's turn our attention to perpendicular lines. Again, we said that perpendicular lines form a right angle, and they have slopes that are opposite and reciprocal. And I have a couple examples here. If my equation is in slope-intercept form, which means y is isolated, I can just read the slope off as the number in front of x. So my slope in this equation is minus 2/3. My slope in this second equation is going to be 3 over 2. And now I see that they're opposite, meaning one is positive, one is negative. Check. And they are reciprocal. How do I know they're reciprocal? Well, the reciprocal of 2 over 3 is 3 over 2. Top to the bottom, bottom to the top. Because both of these are satisfied, I know that these will in fact be perpendicular lines. But again, if it's not given to us in slope-intercept form, we will have to get it in slope-intercept form by isolating our y. Let's take our first equation. I'm going to add 3x each side. and divide by 12 every term. These would cancel and go to 1y. 3 over 12 goes to 1/4 x. 36 over 12 goes to 3. Now, looking at our second equation, if I get it in slope-intercept form, we want to add 16x each side. And then we're dividing everything by our -4. These cancel and go to 1. 16 over -4 is -4, and I have the x. 28 over -4 is -7. And now I can read the slope off. The slope here is 1/4. The slope here is -4. Notice that they are opposite, positive, negative, and reciprocal. 1/4, the reciprocal is 4. So that tells me these are in fact perpendicular lines. Let's look at how these would look on our graphing. So the first set I'm going to graph is y equals -2 over 3, x minus 16. I'm going to have to zoom out. And my second one was y equals 3 over 2, x plus 4. And now you can see that they join up. Essentially, they're making an X, but if you turn your head, you can see they meet at a right angle. Let's look at our second set of lines. We got that y equals 1/4 x plus 3. And for our second equation, we had y equals -4x minus 7. And again, you can see they're meeting up at right angles. So graphing these is an excellent way to check your work. In the next video, we'll talk about how we construct equations of lines that are parallel and perpendicular.
Maybe it's time we put our